Hello, my young students of ninth class. Hope you enjoyed yesterday's conservation of mass. Nowadays, we are thinking more about the conservation of nature, conservation of mass, conservation of thoughts. In the same way, in chemistry, during chemical reactions, mass is conserved. So that only point of discussion yesterday. Now we will continue the same point today to understand more. So I welcome once again for the today's topic on the law of conservation of mass. How does the law of conservation of mass work? When a substance undergoes a chemical reaction, you might assume that some or even all of the matter present is disappearing, but in actuality, it's simply changing form. Think about when a liquid turns into gas. You might think that the matter has simply vanished, but you were to actually measure the gas. You will find that the initial mass of the liquid has not actually changed. What this means is that the substance which is now gas still has the same mass it had when it was a liquid. The answer is yeah. Means earlier it was in the liquid form. Now it is in the gaseous form. H2O is H2O only change of form, liquid to the gas. Okay. If it is closed, we can calculate. If it is open, it will escape. Now, what is the history behind the law of conservation of mass? Though many people, including the ancient Greeks, laid the scientific groundwork necessary for the discovery of the law of conservation of mass, but it is the French scientist Antoine Lavoisier who is most often credited as its discoverer. So, the credit of discovery of the law of conservation of mass goes to Antoine Lavoisier. He has done a great work in the field of chemistry. See, Antoine Lavoisier. This is also why the law is occasionally called on his name Lavoisier's law. In the 1700s, Lavoisier, in the late 1700s, Lavoisier proved through experimentation that the total mass does not change in a chemical reaction, leading him to declare that matter is always conserved in a chemical reaction. So he has done a lot of research work was done on the chemical combinations. Then he has concluded that matter is always conserved in a chemical reaction. Lavoisier's experiments marked the first time someone clearly tested this idea of the conservation of matter by measuring the masses of materials both before and after they underwent a chemical reaction. Now it is for us it looks easy, but you remember during the time of late 1700, so nobody was understanding this law, but it is the Antoine Lavoisier made it very clear. So thanks to the Antoine Lavoisier for making the clear that matter is conserved. Ultimately, the discovery of the law of conservation of mass was immensely significant to the field of chemistry because it proved that matter was not simply disappearing but was rather changing form into another substance of equal mass. This is the most important conclusion. What are the some law of conservation of mass examples? Law of conservation of mass examples are useful for visualizing and understanding this crucial scientific concept. Many are there, so we discuss two examples to understand this law. One is the bonfire, the campfire, what normally we used to do during the picnic trip or NCC camp or adventure camp. Okay, yeah, these are sticks burning, okay, logs of wood. Second is the burning candle, most common what we see in our day-to-day life. So let us discuss one by one. One common example you will come across is the image of a bonfire or a campfire. You have gathered some sticks, okay, with friends and lit them with a match. After a couple of toasted marshmallows and campfire songs, So that is, marshmallow is a sweet candy. And after doing all this work, you realize that the bonfire or the campfire you have built has completely burnt down. All you are left with is a small pile of ashes and some smoke. That is, that matter has gone. No, it is in the form of what? Ash. It is in the form of what? Smoke. It is in the form of what? Some gas. So your initial instinct might be to assume that some of the campfire's original mass from the stick has somehow vanished. Not at all. It simply transformed. Okay. In this scenario, as the sticks burned, they combined with oxygen in the air to turn into not just ash but also carbon dioxide and the water vapor which is escaping to the atmosphere. As a result, if we measured the total mass of the wooden sticks and the oxygen before setting the sticks on fire, I think this mass is equal to the mass of the ashes, carbon dioxide and water vapor combined, which is strictly according to the law of conservation of mass. Now we'll take the example of second, burning candle. A similar law of conservation of mass example is the image of burning candle. A picture a regular candle with wax and wick. Wick means batti. Once the candle completely burns down, though you can see that there is definitely far less wax than there was before you lit it. This means that some of the wax has been transformed into gases, namely water vapor and carbon dioxide. As the previous example with the bonfire has shown, no matter is lost through the process of burning. Therefore, from these two activities, what we can conclude, this is a very important, most important conclusion. Okay, nothing is lost, nothing is created, everything is transformed. So this is the law of conservation of mass. Thank you, my dear students. Thank you for being with me to understand what is the law of conservation of mass.